Well, hello. Today we're going to be talking about the frictional force. So we're going to include mu in this. What I've went ahead and I'm going to tell you how that gets there. I went ahead and put in some information for us. This is all information from previous days and notes, and we're going to start right down here and try to figure out how to find number 4 and 5. Well, how much is the tension in the rope? What I want you to realize is that the tension in the rope, well, right now we know that there is 1,005 newtons pulling this box down this incline. There are two types of forces that's holding it in place. One is the force of friction between the two. The other one is the force of tension. I know that the force of tension and the force of friction have to be equal and opposite to this 1,005 newtons. So what I'm going to say then is that the force of friction plus the force of tension is equal to 1,005 newtons. Well, the force of friction, I know that equation. That is just mu times N plus the force of tension equals 1,005. Mu is 0.15 from the story problem, and N from the story problem we've already calculated to be 2,763 plus Ft equals 1,005. That gives us 414 plus the force of tension equals 1,005. The force of tension then has to be equal to 1,005 minus 414 newtons, which turns out to be 591 newtons. That means that there is a tension force in here of 591 newtons. That means right here there is 591 newtons pulling up. But what is it pulling up on? It's pulling up on the weight of this. So we can say then, if I want to find the mass of this hanging box, it's two steps from here. First, I'm going to say that this 591 equals the weight. Well, what is the weight of this small box? It's mg. It's m of the mass of the small box times gravity of 9.8. Well, if I take 591, divide it by 9.8, I find out that the mass of this box, what is the mass of it? It turns out to be approximately 60 kilograms. And that's the steps. That's the last two components of this. On here, I'm going to give you some hints for it as you go forward on this. This is going to be mg cosine theta. This right here is just mg sine of theta. What is the tension of the rope? Remember, that right there is the force of friction plus the force of tension is going to be equal to number 3 here, whatever answer you get. Alright, put that in for number 3 right there. That's the amount of force. Alright, remember, number 3 is the amount of force that's pulling it down. So we want to put whatever that force is here, because the force of friction plus the force of tension have to be equal and opposite. What is the mass of the hanging box? Well, we say that the force of tension has to be equal to the weight of the small box. So we can say that the force of tension is equal to m times g, and then all you're solving for is m. Well, a real quick lesson here on this today. So all we've done is added to our frictional force. Hopefully you're ready to get this one done, and I'll see you on the flip side.